Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach some algebra. This is lesson 6.2 on radicals and rational exponents. And our question here is, how do you write and evaluate an nth root of a number? And by nth root, we mean like any number. We're familiar with square roots, right? But what about cube roots or fourth roots or fifth roots? So how do you do those? So let's take a look at some core concepts here, and then we'll look at some examples where we explain these. So first of all, the first one is kind of separate from the others. These three are related. Let's take a look at the first one here. N is an integer greater than 1, and a is a real number. So we have this idea here. The nth root of a. Well, that's going to be equal to a to the power of 1 over n, the inverse of whatever root we're looking for. Now, normally, we look at square roots like the square root of 16 equals 4, and we don't normally put the little number 2 here for square root. If we use the radical sign, then without the number there, it means square root. Another important idea is that the radical sign for square root always means the positive square root. And we'll talk about what I mean by that in just a second, because positive numbers can have 2 square roots. Okay, so let's take a look at our examples here, or let's take a look at our core concepts here. If it's odd, if we're looking for an odd root, like a cubed root, let's say the cubed root of 8. Well, what number multiplied by itself 3 times is going to equal 8? And that's 2. Okay, so 2, let me give the other idea up here, down here. 2 cubed equals 8. Okay, so the cubed root of 8 is 2. Okay, so what do we mean by only having one root? Well, if I was looking for the cubed root of negative 8, we have to ask ourselves, what is negative 2 cubed? Well, negative 2 times negative 2 is positive 4, times negative 2 is negative 8. So in this case, the cubed root of negative 8 is negative 2. Okay, so in this case, 8 only has one cubed root, because it's odd. Negative 8 only has one cubed root, because again, we're looking for an odd root, right? A cubed root is odd, and negative 8 only has one cubed root, which is negative 2. Okay, so you're saying, well, doesn't that go for everything? No. So let's take a look at the next line. If n is even and a is positive, and a has 2 real nth roots, a positive and negative. So kind of note this, it's kind of small, I know, on your screen. Positive and negative. So let's take a look at the square root. Let's take a look at square root of 16. Now let's take a look at square root of 9. Okay, the square root of 9 is positive. I'm doing this wrong. I don't want to use that symbol there, because that's not always right. Like I said, it means the positive square root. That's why we have to use the positive and negative symbol there. Okay, so let's say I'm looking for the square root of 9. Okay. Now I'm putting a little number there, so I'm just going to include this here. So I want you to think of I want you to think of the idea here. Like I said, this radical symbol always means positive. But what number multiplied by itself will equal 9? Well, 3, but also negative 3. Okay, because 3 squared equals 9, and negative 3 squared equals 9. So the number 9 has 2 different square roots, a positive and negative square root, 3 and negative 3. Okay, and if a equals 0, then we only have one root, which is, like, of course, 0. And if n is negative, negative numbers have no square roots, because I can't. Let's go back to that first idea, negative 9. What number multiplied by itself equals negative 9? Well, negative 3, well, we saw up here, negative 3 by itself, negative 3 multiplied by itself equals positive 9, and positive 3 multiplied by itself equals negative 9. I can't take any number and multiply it by itself and come up with a negative number, because remember, when those numbers have the same sign, you're going to always come up positive. So negative numbers have no nth roots, no even roots. Okay, let's take a look here. Some examples. We'll find the indicated nth roots of a. So this is asking us for the cubed root of negative 27. Well, I have to think to myself, what number multiplied by itself will get me negative 27, and that's going to be negative 3. Because negative 3 cubed is negative 3 times negative 3 times negative 3, which is 9, times negative 3, which is negative 27. Okay, so that's negative 3. And this one's asking for the fourth root of 16. Well, I ask myself, what number multiplied by itself as a factor 4 times is going to get me 16? And that's 2. I don't want to put the fourth there, just 2. Because 2 to the fourth power is 2 times 2 times 2 times 2, which is 16. Okay, so those are some simple examples. Let's take a look at some harder examples here, because these have the negatives and all these things here. Okay, let's take the first two together here. The cubed root of negative 8, and this is the opposite of the cubed root of negative 8. Whenever you see this negative sign in front of something, think of it as negative 1 times whatever comes after it. So this expression, cubed root of negative 8, is the same as this one. So when we do this one, we'll have the answer to this one. Okay, so cubed root of negative 8 going to be negative 2, because negative 2 cubed equals negative 8. Remember, negative 2 times negative 2 is positive 4, times negative 2 is negative 8. So my answer here is negative 2. So my answer here is going to be negative 1 times negative 2, or positive 2. This basically says the opposite of whatever this is. So the opposite of negative 2 is 2. This example, 16 to the power of 1/4, that's really the fourth root of 16. And I have to think, I can break this down using a factor tree. So 16 is 8 times 2. 8 is 4 times 2. And 4 is 2 times 2. Now I've got all prime numbers here, but the nice thing about this, because I'm looking for a fourth root, I've got 4 2's. That means that that's going to be my fourth root. Okay, so I know that 2 to the fourth power is 16. So the fourth root of 16 is 2. Let me move this here. Fourth root of 16 is 2. But then what do we know? What do we know about even roots of positive numbers? Positive and negative. And again, this sign always means positive, but they wrote it like this because they want to emphasize positive and negative too. Okay. This is the fourth root of negative 16. Now, our core concepts before, what did it say about even roots of negative numbers? Doesn't exist. Okay, so there's no answer for this one. This one cannot be answered. This one does not have, negative 16 does not have a fourth root. So if it was, because positive and negative 2 are both going to get me positive 16. So that, there's no answer for this one. I don't say no solution because it's not an equation, but I can basically say like not defined or undefined for that one. Okay. Next core concept. We want to let, okay, so it's this idea now we're multiplying, or not multiplying, we're raising a base number, in this case a, to a fractional exponent. The denominator, think about what we just did on the previous screen. The denominator tells us what root we're going to use. So 17 and 2/3, or 27 raised to the power of 2/3. Well, that denominator still tells us it's a cubed root we're looking for, right? And the numerator, well, we're just going to square the whole thing now. That's kind of left out. That's our numerator. So that's how we're going to translate these things. So let's take a look at some examples and see if we can figure them out. Evaluate 16 to the power of 3/4. Okay, so 16 to the power of 3/4 is really the fourth root of 16. Whole thing cubed. Okay, so I know the fourth root of 16. We did this with 4. The fourth root of 16 would be positive and negative 2. That's raised to the third power. Okay, so positive 2 to the third power is going to be 8. And then negative 2 to the third power, negative 2 times negative 2 is positive 4, times negative 2 is negative 8. So positive and negative 8. 27 raised to the power of 4/3. Well, again, this is the cubed root of 27, all raised to the fourth power. The cubed root of 27, okay, it's an odd number root, so there's only going to be a single root in this case. It's only going to be 3. 3 times 3 is 9, times 3 is 27. This is 3 to the fourth power. 3 times 3 is 9. 3 times 3 is 9, so this is going to be 81. Only 81. Okay. If you're not sure what about this, back this up. Look at it again. Take some good notes. Let's take a look at these guys are called the Animaniacs. That's right, from the early 90s. And if bring your questions to class, we'll practice in class, and I will see you then. Bye-bye.